And welcome everybody to the Daily Space Weather. Exciting stuff going on once again, including another coronal mass ejection headed Earth's way. Sunspot 2882, this active region right here, has gained in complexity. The likelihood of solar flares has gone up. The likelihood of coronal mass ejections has gone down. Here's a close-up of Sunspot 2882 and 171 angstroms from the Solar Dynamics Observatory. Just spectacular imagery here. This is now a beta-gamma class sunspot. The likelihood of major flares much higher now than it was yesterday. The likelihood of coronal mass ejections, well, similarly low to yesterday. We had missing data. Let's get into that. No modeling yet from NASA or NOAA. So looking at the viewpoint from Lagrange point 5, the location of the Stereo A spacecraft, here's its coronagraph. You can see at around 10 o'clock on the 7th, yesterday, we saw a major CME out of both sides of the sun here happening at the same time. And the portion that is on the Earth side, which is indeed this portion over here, the Earth would be off in this direction. Anyway, looking at the right coronagraph here, that's the LASCO C3. And you can see ejecta on all sides of the coronagraph. You see that? That is what an Earth-facing coronal mass ejection looks like. The LASCO C3 is located here at Lagrange point 1 between the Earth and the Sun, about 1 million miles. 92 million miles from the Sun instead of 93 where the Earth is located. So there's another Earth-directed coronal mass ejection. We can expect that to arrive sometime on the 10th. It's pretty diffuse. There was a high-speed moment there, but it's fraught with missing data. Anyway, we deductively figured this one out yesterday, that it happened even though it wasn't visible due to a lack of data. So anyway, we'll just let those play again. Lagrange point 5, Stereo A on the left, the LASCO C3 coronagraph on the right. It's another Earth-facing coronal mass ejection. It's direct. The ejecta is going to strike the Earth geospace. It's going to be a minor strike because it's very diffuse. But hey, them's the facts. Them's the facts. Let's break out some more imagery of the sun here. You can see the complexification of Sunspot 2882. There is a little bit of South Pole umbra there to the north of that sunspot. So again, likelihood of significant solar flares much higher as a result of that. Here's a full disk view in 304 angstroms ionized helium. Again, coronal mass ejection watch has been exhausted. No need for a coronal mass ejection watch, but solar flare watch now much higher likelihood of major flares. Here's a composite image, series of images really, 304 and 171 angstroms. One of my favorite composites from the SDO. Only one sunspot group at the moment on the Earth portion of the disk, Earth-facing portion of the disk. The radio flux, which is the radio frequency output from the upper chromosphere and the lower corona, now at 86 solar flux units. Here's a one-year chart of the radio flux. It's the black line here. The red line is the sunspot number. And we see no modeling for this coronal mass ejection yet from NOAA at the Space Weather Prediction Center on the Space Weather Enthusiast dashboard. No modeling there. I don't know if they're aware of it yet, if they're asleep at the wheel, or what the deal is, but in any case, there's a Space Weather Enthusiast dashboard. We can expect that to arrive around midday on the 10th, mid to late day on the 10th. I would say there should be a signal from that coronal mass ejection. Next, a brief look at global seismicity. We did see one quake over a 6 magnitude here. that occurred way down here in the Southern Ocean here south of Australia and New Zealand. There was also a 5.9 at Japan. That was the second largest quake. Let's do a quick look at the location of that one. Right in Tokyo Bay there, folks. So a highly populated area there. Fortunately, Japan has extremely strict building codes. So some quakes in Alaska and the western U.S. There was also a 5.5 at the South Sandwich Islands region. The most seismically active portion of the planet for the last month, I'd say. Philippines saw a deep quake. A 5.2 magnitude at 182 kilometers depth. Also a deep quake at Myanmar. That was a 5.5 magnitude. Here's the largest. It was a 6.1 near the Macquarie Islands in the Southern Ocean. That happened at 2013 Universal Time last night. Some Californian quakes. Leave us a comment if you felt those. A deep quake at Fiji at 4.2, nearly 500 kilometers depth there. Also a deep quake in western South America. That one in Argentina, a 4.5 at a little over 203 estimated kilometers depth. Next, looking at volcanism here, and here's La Palma. Two main lava tongues here, including this new real estate created in the ocean. Maybe don't build a house on that lava flow yet. The volcano is still erupting. Let's see what else is going on. There are some lava tubes from Cumbre Vieja. So yeah, great picture there of the new real estate created. Shivaluch now back on the list. Volcanic ash not identifiable in satellite imagery. Don't assume it's not erupting. Although there aren't a lot of people on the Kamchatka Peninsula to notice if it is. Subanose-jima exploded. 5,000-foot ash plume from Subanose-jima. Popocatépetl volcanic ash not observed. Don't assume it's not erupting. Volcanian activity continues from the summit crater. Seismic activity also associated with Popocatépetl. Fuego exploding, flight level 150. It's producing a 15,000-foot plume of volcanic ash. Nevado del Ruiz volcanic ash not seen. It must be some cloudy days for the satellite. Sangay exploding in Ecuador, 19,000-foot ash plume there. Sabancaya, unable to detect Sabancaya. Nevados de Chilean exploding, 13,000-foot ash plume from the central Chilean volcano. Please don't pole vault the caldera. Please make Earth not suck again. It's up to you, folks. It's up to you and the Smash News Network to make Earth not suck again. I'm wearing the hat. Mensa, make Earth not suck again. It's a motto that I live by. Why? Because I'm well aware that it is not giant bureaucracies, completely inept corporations and governments to make Earth not suck again. It's up to you individual people to make Earth not suck again. So do your part, make Earth not suck again. Tell your friends and foes about it with our multiple products here, such as the high-quality hat. And by the way, it's high enough quality that you can read this small URL on my hat. You can find all of that at our Redbubble shop. So check it out. We've put these in order of popularity. And thanks to everybody who's picked up merch. I would say, Universum Liberate. Join the Galactic Federation Special Forces. If you haven't yet, just click on SMASHO merch on our homepage at smAshomash.com. You can also find a link to the Smash team there. We've replaced Patreon with something vastly superior. If you'd like to support our efforts and get all kinds of information nobody else gets to see behind the scenes, join the Smash team, smashomash.com/Smash team. Let's take a look at some magnetic data next. And the GOES magnetometers have been in a tight range here. We're seeing higher lows and lower highs for the last 24 hours. There is a bit of magnetic indecision going on the Earth-facing portion of the solar disk. Let's take a look at the heliospheric current sheet. And this is showing North Pole orientation in green, South Pole orientation in red. The heliospheric current sheet. The plasma in it is polarized by one or the other pole, making it primarily North or South Pole. North Pole shown in green, South Pole shown in red. And here's the latest image. There is a South Pole current sheet headed this way. And when that will arrive is determined by the active regions on the Earth-facing portion of the disk. No forecast to be made there. Keep in mind the magnetic environment can suddenly change. Here's the line of sight view of basically the same data. It also shows you the solar magnetogram. And you can see this blue line shifting around. I am undecided where I think it will be by tomorrow. Keep in mind the data is nearly an hour old from when we recorded the video. Here's the line of sight coronal hole plot, and you can see some transequatorial coronal holes here. Some rotating right through the Earth-facing zone. Those are North Pole green oriented. There are some South Pole ones trailing that. So finally seeing some transequatorial coronal holes of both polarities. Also the sun's B field shown in this animation in blue. And here's our coronal hole visible imagery from the SDO. It's 193 angstroms. Not super well-defined coronal holes, but they are stretching across the equator. So again, likelihood of major flares has gone up here with the complexification of Sunspot 2882, now classified as Beta Gamma class. It has a little bit of South Pole ombre to its north, which is enough to raise the probability. So there was a couple of C-class flares yesterday on October 7th. Again, expect to see more flaring today as a result of that increase in complexity. No spikes in the proton flux. The flares that we've seen have not sent any relativistic particles to Earth yet. Next, the real-time solar wind. It's pretty unremarkable over the past 24. Current conditions are only 293 kilometers per second. Okay, that's pretty remarkable. That is an extremely low speed solar wind. 293 kilometers per second. Solar wind density 8.05 protons per cubic centimeter. Only enough to get the KP index, a measurement of global geomagnetism, to 1. KP1. Geomagnetic calm conditions. Here's what's going on in the geospace according to the Space Weather Modeling Framework. The Space Weather Modeling Framework. It's 4 hours of data if all is working well. And you can see most of the magnetohydrodynamic pressure here expected to be on the magnetotail side of the planet, as opposed to the sun-facing side, which would be to your left. Since it refreshed, we're going to let it play through because we keep it raw. To quote the Wu-Tang Clan, we keep it raw and we don't edit the videos. This way they get onto your screen more quickly. And congratulations on realizing that our channel exists. Again, 4 hours of data there, pretty uneventful. Next, ground magnetic perturbations. Since there's a polar excursion going on, perhaps there's always a polar excursion going on. I don't know why everybody's so frightened of it. It's just not particularly scary to me. Let us know if you're frightened in the comments. And explain if there's any physics behind your fear of the polar excursion. Anyway, like the last frame, that's 4 hours of data. Ground magnetic perturbations, geospace delta B. Here's where stuff is located in the solar system. Mars looking lonely on the opposite side of the sun. Let's advance this 1 week. There we go. In 1 week, we'll have a gibbous waxing as Venus catches up to pass the Earth once again. Next, a star chart we've drawn in the galactic plane and the ecliptic here for your convenience. This is what's going on above my head. Mine's facing the south. And if you want to make one of these yourself, go to Charts, click on All Sky Charts. Put in your location, and you'll be able to see what's going on above your head as well. We'll do a brief cosmology segment. This will be integrated into the daily space weather video. Once again, don't forget to check out our playlists. We've got dozens of playlists on the channel, youtube.com/smAsho/playlists. The cosmology segments playlist has over 200 videos in it. Let's talk about quasars. Quasars were not understood in the mid-90s. Now they're understood as a product of orientation. And so where you're located determines what a galaxy may look like. If you're viewing a galaxy edge on, it's likely to be a radio galaxy. If you're viewing the galaxy from near the jet, it's more likely to be a quasar or even a blazar if you're right in the middle of the jet. It's all about orientation. If you want to read about quasars, there's an article about it on Wikipedia. Today's featured quote random and quote object is quasar B1722 plus 119. So that's on the Neil Gehrels Swift Bat X-ray Observatory, which looks like this. Those are the transients from the Neil Gehrels. And number 651 is this quasar. These are the hard X-rays from the quasar over the past 16 years and over the past 30 days. And you can see it's a fairly consistent X-ray source here over the past 16 years. And let's take a look at this visually. All right, so we're just going to go down the electromagnetic spectrum here. Here it is on the Galix. This is the ultraviolet spectrum. And I do believe there is an associated galaxy here, a satellite galaxy or perhaps a merging galaxy going on. And you can see a minor UV signal. It'll show up a little better in other wavelengths. How about the Pan-STARRS optical survey? You can see that other galaxy there. Perhaps it is in the foreground. Very hard to say, and it all is because of the orientation of these galaxies. Those are all active galactic nuclei, folks. Now, if we look at it on the 2 mass, it looks like almost like there's a thermal bridge in between those galaxies. So who knows, maybe there's some kind of a jet interaction. Maybe those galaxies are somehow bound. But in any case, that's the infrared spectra of that quasar. Again, it's quasar B1722 plus 119, number 651 on the Neil Gehrels Swift Bat X-ray Observatory. Let's take a look at the astronomy picture of the day. It's 2 open clusters located in the Milky Way galaxy in the constellation of Perseus. And you can see those great open clusters there. Open clusters are similar to globular clusters, except that they are not all orbiting each other. That's NGC 869 and NGC 884. So this is 884, New General Catalog, and this is New General Catalog 869. The astronomy picture of the day at apod.nasa.gov. That's today's cosmology segment. Again, don't forget to check our playlist for hundreds more videos about cosmology. Next, checking charging hazards, and we don't see any at the moment. Continuing on, here's the relativistic electron flux. These electrons are primarily in the inner Van Allen belt, folks, and these measurements are made at the F ionosphere layer by geosynchronous satellites like the GOES 16 and GOES 17. Here's their last 3 days of data, and we're expecting higher levels here. Here's the forecast model, and I would expect this to be up a little bit higher here in the coming days, but not off by a whole lot. We'll see what happens. Here's another diagram of Earth's Van Allen belts. Feel free to pause the video. Distances are shown in miles. And here's the total electron content forecast. So the total electron content is good at showing the likelihood of GPS errors. It also shows us if there's disorganization going on in the inner Van Allen belt. This is the whole air column in between your geosynchronous satellite and your GPS handset, and everything's looking fairly normal here. No major anomalies happening with the inner Van Allen belt. Next, we're going to show you the F ionosphere layer, located at about 300 kilometers of altitude. Here is your ionogram. And we did note some major anomalies in yesterday's daily space weather video. They are less significant today. They were significant enough yesterday to make it onto our thumbnail. And they're largely located in the same place, mainly around South America and the Central Pacific Ocean. Now we are seeing some significant anomalies there west of the South American continent. Here's the anomalygram showing a departure from the 30-day median in megahertz. You can see some major low-frequency anomalies around Central America. And again, high-frequency anomalies in the Central Pacific. High-frequency anomalies showing up in blue, low-frequency anomalies showing up in red. Here's the latest image. That's 8:45 Universal Time. And there is the ionogram. Ionogram, anomalygram. It's time. Time to do bonus features and chew bubblegum. And I'm all out of bubblegum. We're going to look at the El-Teide ground-based solar observatory here. Here's the latest hydrogen alpha imagery from El-Teide. Significant filaments down here. You can see some brightening here of Sunspot 2882. Maybe some flaring activity going on as we made the video. Here's the latest imagery of 2882, and you can see still there is a series of umbrae to its north, increasing the likelihood of major flares. That red portion, that is a South Pole umbra, making it a beta-gamma class sunspot. So here it is in close-up form in 1700 angstroms. That's extreme UV light. And you can see that area forming above it. That's the last 24 hours approximately. Here it is in 94 angstroms. 94 angstroms, like 131 angstroms on the SDO, takes 10 images per minute instead of only 2, so we've got 5 times the temporal resolution here in this wavelength. Again, 94 and 131 angstroms are specifically taking more images per minute to study things like solar flares, sunspot activity, and so on. And last but not least, here's some composite imagery. This is 171 angstroms and 1700. So it's about that time. Thanks again for tuning in, viewers. Congratulations on realizing our channel exists. Please support the channel financially via the links below the video. And may that solar wind be at your back.